Conservation of energy in the case of a freely falling body. If a body is dropped freely, then it comes down. While coming down, its potential energy will be converted into kinetic energy. Initially, the entire energy is potential energy. When the body is at certain height, initially its energy is potential energy. As it is dropped, it has no kinetic energy. As it comes down, its potential energy will be lost because it is decreasing in height. The loss in potential energy will be equal to the gain in kinetic energy. The amount of potential energy lost by the freely falling body will be converted as kinetic energy of the body. Initially, the entire energy is potential energy, but finally, before it just touches the ground, before just it reaches the ground, the entire energy will be converted as kinetic energy. Initial energy is potential energy. Just before hitting the ground, its energy is totally kinetic energy. Let us consider a freely falling body. And let us take three positions. 1. When it is dropped, that position is indicated by A. And let us suppose the mass of the body is m. It is dropped from the position A. After coming down through a distance x, suppose its position is B. And its height from that position is h minus x, where h is the total height, initial height. Just before touching the ground, the position is say C. Then its height will be 0. So let us consider three positions of a freely falling body. The mass of the body is m. Initially it is at a height h at the position A. After coming down through a distance x, the position is B and its height will be h minus x. When it just touches the ground, just before touching the ground, its height is 0 and that position is C. The energy of the body at the three different positions. At A, the energy of the body is entirely potential energy, so it consists of only potential energy. When it is at B, it will have both potential energy and kinetic energy. And when it comes to C, the entire energy is converted as kinetic energy. So while coming down, potential energy is converted into kinetic energy. The energy at A is only potential. The energy at B is both potential and kinetic energy. Just before touching the ground at C, the energy is entirely kinetic energy. At A, potential energy is mgh. At A, potential energy is mgh. Kinetic energy is 0 because it is just dropped, its velocity is 0, hence kinetic energy is 0. The total energy is capital E, that is equal to Pe plus Ke. Pe plus Ke is the total energy, total mechanical energy. Total mechanical energy E is equal to Pe plus Ke, that is equal to mgh plus 0, that is equal to mgh. Hence, the total energy at A is equal to mgh. When the body is at B, its potential energy is mg into h minus x. Because its height is h minus x, the potential energy of the body at B is mg into h minus x. The distance traveled is x, so the loss in potential energy is equal to mgx. This will be converted as kinetic energy. Hence, kinetic energy is equal to mgx. So the total energy is equal to Pe plus Ke, that is mgh minus mgx plus mgx. mg into h minus x is mgh minus mgx plus Ke is mgx. So total energy is mgh. So at B, the total energy is mgh. Mathematically, we can show that the kinetic energy at B is equal to mgx. We can show that the kinetic energy at B is mgx. Let us derive this. Initially, its velocity is 0 because it is dropped. The final velocity is say v. At B, the velocity is say b. Then the distance travelled is s is equal to x. The acceleration a is equal to g. From the relation v square minus u square is equal to 2as. From the relation v square minus u square is equal to 2as, v square minus 0 square is 2gx. 2gx. So v square is equal to 2gx. Kinetic energy is half mv square, but v square is 2gx, but v square is 2gx. Hence kinetic energy is equal to half m into 2gx. That is equal to mgx. 2 gets cancelled, so kinetic energy is equal to mgx. At C, potential energy is 0 because the height of C from ground is 0. Just before touching the ground, the height becomes 0, so potential energy becomes 0. And the distance through which it has traveled is h, so the kinetic energy becomes mgh. The potential energy will be entirely converted into kinetic energy, hence it is equal to mgh. So the total energy is equal to Pe plus Ke, that is 0 plus mgh, that is equal to mgh. That is equal to mgh. Now let us show that Ke is equal to mgh. Let's see, the kinetic energy is mgh. Let us show this. Initially, the velocity is 0 because it is just dropped. The final velocity is say v, and acceleration a is equal to g, displacement s is equal to h. So from the relation v square minus u square is equal to 2as, v square minus 0 square is equal to 2gh, or v square is equal to 2gh. Therefore, kinetic energy half mv square becomes equal to half m into 2gh. 2 gets cancelled. So Ke is equal to mgh. Energies at A, B and C in a nutshell. Let us consider the point A. At A, the potential energy is mgh and the kinetic energy is 0. Total energy E is equal to Pe plus Ke, that is equal to mgh plus 0, that is equal to mgh. So the total energy at A is mgh. At B, potential energy is equal to mg into h minus x, kinetic energy is mgx, total energy is Pe plus Ke, so it is equal to mgh minus mgx plus mgx is equal to mgh. So total energy at B is also equal to mgh. At C, potential energy is equal to 0, kinetic energy is mgh, and the total energy E is equal to Pe plus Ke, that is equal to 0 plus mgh, that is equal to mgh. Thus we find the total energy either at A or at B or at C is the same, which is equal to mgh. Conservation of energy in the case of a vertically projected body. Conservation of energy in the case of a vertically projected body. Let us suppose a body is thrown up with a initial velocity u in the vertically upward direction. And let us consider its mass to be m, and its positions are A near the ground, B at a height x, and C at the maximum height small h. A, B, C are the three positions. A is just on the ground, B is at a height x, C is at the maximum height. At A, the total energy is composed of potential energy and kinetic energy is equal to, potential energy is equal to 0 and kinetic energy is half mu square, so the total energy is half mu square. At B, total energy is equal to Pe plus Ke, that is equal to mgh potential energy plus half mu square minus mgx, that is equal to half mu square. Mgx is potential energy, half mu square minus mgx is kinetic energy, so total energy is half mu square. At C, potential energy is half mu square and kinetic energy is 0, so the total energy becomes half mu square. Now I will show how the energy changes at different positions. At A is a point on the ground, so its potential energy is 0 since height h is 0. At A, potential energy is 0, but it is given a velocity u, so its kinetic energy is half mu square. So total energy is equal to Pe plus Ke, that is equal to 0 plus half mu square, that is equal to half mu square. So at A, potential energy is 0, kinetic energy is half mu square, and total energy is half mu square. At B is at a height x, so its potential energy is mgx. B is at a height x from the ground, so the potential energy is mgx. We can show that the kinetic energy is half mu square minus mgx. Kinetic energy at B can be shown to be equal to half mu square minus mgx. So when we take the sum of these two potential and kinetic energies, we will get mgx plus half mu square minus mgx, which becomes equal to half mu square. Half mu square. Now I will show you that kinetic energy is half mu square minus mgx. Let us consider the motion from A to B. At A, its velocity is u. Its velocity is u. It is in the upward direction. Let us find the velocity at B. Acceleration A is equal to minus g. Displacement s is equal to x. U is equal to u. V is how much? A is equal to minus g. S is equal to x. Take the relation v square minus u square is equal to 2as. In this relation, v square minus u square is equal to 2 into minus g into x. 2 into minus g into x. Hence, v square is equal to u square minus 2gx. v square is equal to u square minus 2gx. Kinetic energy at B is half mv square because velocity at B is v, so kinetic energy at B is half mv square. But v square is equal to u square minus 2gx. Therefore, kinetic energy is equal to half m into u square minus 2gx. Half m into u square minus 2gx. That is equal to half mu square minus mgx. Half mu square minus mgx. Now let us consider the position C. C is at a height h. At this height, the velocity is 0. So we can show that potential energy is equal to half mu square and kinetic energy is equal to 0. The total energy is sum of these two. Hence that is half mu square plus 0, that is equal to half mu square. Kinetic energy is 0 because velocity is 0. Now let us prove that potential energy is equal to half mu square. Consider the motion from A to C. At A, the velocity is u and it is in the upward direction. The final velocity at C, v is equal to 0. Acceleration A is equal to minus g. The displacement s is equal to h from A to C. U is equal to u, v is equal to 0, A is equal to minus g, s is equal to h. From the relation v square minus u square is equal to 2as. From the relation v square minus u square is equal to 2as. 0 square minus u square is equal to 2 into minus g into h. From which minus gets cancelled and we will get 2gh is equal to u square. Therefore, h is equal to u square by 2g. h is equal to u square by 2g. Potential energy relation is mgh. P is equal to mgh. But h is u square by 2g. h is u square by 2g. So that is equal to P is equal to mg into u square by 2g. Gg gets cancelled and we will get half mu square. So potential energy at C is equal to half mu square. At a glance, conservation law of a vertically projected body. At A, P is equal to 0, K is equal to half mu square. So total energy is equal to Pe plus Ke, that is 0 plus half mu square is equal to half mu square. At B, P is equal to mgh, K is equal to half mu square minus mgx. So total energy is Pe plus Ke, that is mgx plus half mu square minus mgx, that is equal to half mu square. At C, P is half mu square and Ke is 0. So total energy is Pe plus Ke, that is half mu square plus 0 is equal to half mu square.